An aluminium rod has a length of 50 meters at 300 Kelvin. Find the temperature at which its length would be 49.9 meters. Given the alpha L value, the linear expansion coefficient of aluminium is 25 times 10 to the minus 6 Kelvin inverse. Now, we might be familiar with most of the data, like the length and the temperature, but we might be wondering, what is alpha L? What is the meaning of linear expansion coefficient? Well, it just means that if you have an aluminium rod of 1 meter and you heat it up and increase its temperature by exactly 1 Kelvin, then the rod would expand by 25 times 10 to the minus 6 meters. That's the meaning of this number. And similarly, if you were to cool it down by 1 Kelvin, decrease its temperature by 1 Kelvin, then the rod would shrink in size by exactly 25 times 10 to the minus 6 meters. That is the meaning of alpha L. And we have discussed a lot about this in a previous video. So if you find this a little bit confusing, or maybe you require more clarity on this, it would be a great idea to go back and watch that video first and then come back over here. Alright, so with this, I want you to pause the video and see if you can use this information and logically try to solve this problem. Alright, let's solve this. Let's first write down what's given to us. We know that the length of the rod, the length of the aluminum rod is 50 meters. Here, 50 meters. And the temperature right now is 300 Kelvin. Find the temperature at which its length would be 49.9 meters, which means the initial length is 50, the final is 49.9, so the change in the length, that's important for us, the change in the length required would be, let's see, how much is that? 49.9 minus 50, and that would be minus 0.1 meters. The minus sign is just telling that we want the rod to shrink in size, that's all, nothing else. So we want the rod to shrink in size by 0.1 meter. The question now is to what temperature we should cool it down, right? Because we want it to shrink. Okay. The first thing we'll do is try to connect delta L, temperature, length, and alpha L, everything. We'll try to build a connection between them. And the way we like to do that is we can say delta L equals alpha L. Delta L equals alpha L when we have 1 meter long wire or 1 meter long rod and the change in temperature is 1 Kelvin. But what if we had 2 meter long wire? What would be delta L in that case? Well, if we had 2 meter long wire, we could assume it is made up of two 1 meter long wires, and each one would expand by alpha L, and therefore the total expansion will be 2 times alpha L. Does that make sense? So the total expansion will be twice. Similarly, if we had 3 meters, the total expansion would be thrice. If we have L meters, let's do it in general first. If we have L meters, then the total expansion would be alpha L times L. Oops. Times L. Oh, that makes sense, right? But this would be for 1 Kelvin rise. What would happen if we had 2 Kelvin rise? Oh, this whole thing would be doubled. What if we had 3 Kelvin rise? Tripled. What if we have delta T Kelvin rise? Ooh, in that case, we would just have to multiply this by delta T. So now that we have this connection, let's see what we know. We know delta L. We know alpha L. We also know L. We just have to now calculate delta T. So we have now reduced the problem to mere algebra. So whatever follows, no longer physics, is just algebra. So how do we extract delta T from here? Well, we just divide on both sides by alpha L times L. So let's do that. If we divide on both sides by alpha L times L, we get delta L divided by, delta L divided by, I want pink color, alpha L times L, and that would be equal to delta T. And now we can just substitute. Delta L is 0.1. You can substitute minus 0.1. We can do that. No problem. Minus 0.1 meters divided by alpha L is just 25 times 10 to the minus 6 Kelvin inverse times L, and L is 50. Alright, so let's just quickly solve this. What do we get? By the way, this is 50 meters, so the meters and meters cancel. we can take the 10 to the minus 6 upstairs. That will become 10 to the plus 6. 10 to the plus 6 times 0.1. That will be 10 to the power 5. So we can write that as 10 to the power 5. So 1 and 5 zeros divided by 25 times 50. So 1 0 cancels. 25 goes 4 times. So we get 400 divided by 5. That gives us, oh, there's a negative, by the way, there's a negative sign. So that gives us minus 80 Kelvin. What does the minus sign say? Well, the minus sign is just saying that we have to decrease the temperature by 80 Kelvin. And that makes sense because we already discussed that we have to cool it down. So we have to decrease the temperature by 80 Kelvin. But the question is, what is the final temperature? Well, the current temperature is 300. We need to decrease the temperature by 80. So what is the final temperature? Well, let's just write that down. Make some more space here. All right. So the final temperature would be the current temperature 300 minus 80. And that would be 220 Kelvin. Ta-da! That is the answer. So that is the temperature at which the whole thing would shrink to 49.9 meters.